Hello friends, in this video I will be taking up an question on integration from CBSE mathematics paper for the year 2018. This is question number 27 in the paper, whose link I have provided in the description of this video. We have to evaluate this integral. Now, this is a question from the definite integral section. Now, this question creates certain doubts when a student first gets this question because first instinct is to apply certain properties of definite integrals, because in this exercise where this question is listed, this is in the miscellaneous exercise of NCERT, but still since it is a question from definite integral section, students try to apply certain properties of definite integrals. But this question does not lend to any properties suitably. So what we have to do is we will solve it first as a corresponding indefinite integral, and then after the result is obtained we will apply the limits to get the final answer. So we will consider the indefinite integral. Now whenever we wish to solve this type of question, our hint for substitution is the numerator. So in the numerator, if we have sin x plus cos x, then substitution should be put sin x minus cos x as t. If however in the numerator we have sin x minus cos x, then we will put sin x plus cos x as t. So this is the basic rule whenever we wish to evaluate this type of integral. The logic of these two rules will become clear from the solution of this problem. The difference in the substitution, difference in the expression in the numerator, in this case can be just the sign, means it can be cos x minus sin x in the numerator. Still we will make this substitution whatever be in the denominator, because the questions are designed in such a manner that denominator will be adjustable in the form of t or some suitable power of t. So in this question we will put sin x minus cos x equal to t. Now with that substitution, if t is sin x minus cos x, then we take the derivative, which is cos x plus sin x. So our numerator gets adjusted beautifully in the dt term. So one of our problem in substitution is resolved. So basically we have identified that with the substitution this quantity will become dt. Now our next step will be how to adjust the denominator in terms of t. So for that we will square this t term, squaring both sides. So we arrive at this place. Therefore sine 2x becomes 1 minus t square. So both our major problems in the questions on substitution have been resolved. So now we can proceed with the actual process of integration. So my integral transforms to this integral 25 minus 9 t square. This one is this can be converted into dx upon a square minus x square form. So I will take this 9 common from the denominator. Now this integral is of the form integral of dx upon a square minus x square, which is a standard integral with the result 1 upon 2a log of magnitude of a plus x upon a minus x. So using this result, my integral becomes 1 upon 9, 1 upon 2 into 5 by 3, which here behaves like a into log of a plus t divided by a minus t. So my final result becomes 1 upon 30 log of magnitude of 5 plus 3t upon 5 minus 3t. Now we had substituted t as sin x minus cos x. So if we wish, we can convert this integral back to x terms. So going back to the original integral, our answer for the integral with limits will be 1 upon 30 x varies from 0 to pi by 4. First, we will put the upper limit in this expression that will make this factor 0. So we will be left with log 1. Next, we subtract the result obtained by putting lower limit, which will be, now when I put x is equal to 0, sin x becomes 0, cos x becomes 1. So the numerator becomes 5 minus 3, denominator becomes 5 plus 3. Log 1 is 0. So we have log 2 upon 8. Log 1 upon 4, and adjusting this negative sign, we can write it as 1 by 30 log 4. So that is our final answer. Thanks for watching.